We have started with electrochemical
Yes,
cell.
sir.
Yes. Electrochemical
Yes, sir.
cell is made up of two half cells, and these two half cells react to give or to generate electrical energy. So we have described, or we have started describing half cell. Yes or no? What does one
Yes,
half
sir.
cell consist of? Yeah. Half cell, one half cell. Any half cell in an electrochemical cell consists of an electrode and an electrolyte. Yes or no? This we have done last time in my previous lecture. Then we have discussed that there are four different types of half cells or half electrode we say. So which are they? I have already mentioned over here. What are these four different kinds of electrodes?
Metal, metal ion, non-metal, non-metal ion, metal sparingly soluble salt, and redox.
Yeah. So now uh, we have done with, or we are going to do describe this in detail. Yes. So first one, metal metal ion. So how will you describe a metal metal ion electrode? Say for example, this is my half cell which contain an electrolyte. So the electrolyte will be a metal ion solution, and
Sir, pure metal.
yeah, metal. So now this is our first type of half cell, or you can say electrode. And metal metal ion means what? There will be a solution, there will be an electrolyte placed here. Suppose say the electrolyte is placed here. Okay, this is an electrolyte. This one is an electrolyte. This is a metal rod, solid metal rod inserted in an electrolyte. So this will form one half cell. Now why we say it is a metal metal ion electrode? Because here the special part is that metal is common. Say for example, if you take copper, so the solution will contain copper ion. Any salt which is containing copper, so when it is going to get dissolved, the solution will contain what? Copper ion. So the copper ion solution will be placed here, and the rod will be made up of copper. So we say it is metal metal ion solution. Are you getting it? Hello.
Yes.
Did you understand everyone? What do you mean by metal metal ion solution?
Yes, sir.
Electrode. The electrolyte is made up of metal ion solution, and the same metal ion solution will be used for,
Oh,
Electrode.
yes, used as an electrode for electrical connection. Is it clear?
Yes, sir.
yes,
Yeah.
sir.
So this is our first type. So uh, let us go for one of the example. Come on. I gave you one example. Now any one of you can give me another example.
zinc,
So
Chromium.
one second. Zinc. How are we going to go for zinc? What will be present in the solution? What will be there in the rod?
In solution, there will be zinc ion and metal will be zinc.
Zinc ion, say for example ZnSO4. Yes,
Yes, sir.
zinc
yes sir,
sulfate, and the rod will be made up of solid zinc. Yes. Another one, chromium. Somebody told, yes or no?
Yes.
So chromium ion and the rod will be made up of chromium. So there are various such what you can say,
Manganese.
manganese is there, various metals are there,
Iron.
which we can use as metal ion solution. Lead is there, copper is there, zinc is there, iron is there, cobalt is there. Yeah, the one which has rod or which is solid, we can use in such type of our, we can construct our half cell by using this kind of, there is the, oh, okay, we can construct this type of metal ion electrode. Is it clear?
Yes, sir.
Okay. Now let us move towards another part. Now what is the another part? The second one.
Non-metal, non-metal.
Yeah, non-metal ion electrode. So now what will be present over here?
Non-metal ion and non-metal solid.
Now can you give me example of any non-metal?
graphite,
Graphite is a
Brom
carbon. It we cannot go for iron for graphite.
chlorine, bromine,
Yeah,
iodine.
chlorine, bromine, iodine is there. Lot of, as you go and see the periodic table, lot of non-metals you will see.
Same.
Majority of them are metals, but in electrochemistry, so yeah, we use halides. Yes, then hydrogen. Okay, even though it has positive character, but it is one kind of non-metal. Then yes, usually what other non-metals you can use?
Sulfur.
Sulfur is a metal.
Nitrogen.
Nitrogen, yeah, but majority of the time we are not using nitrogen. So basically you can see hydrogen, halides. These are the most common non-metals which are going to be used as a non-metal ions. So now suppose if we consider chlorine ion, how will you get chlorine ion in the salt, in the electrolyte? Cl minus, how will you get in the electrolyte? Which salt we are going to use?
HCl.
Okay. So very simple. When you are going to use, suppose say HCl, there will be Cl minus ions in it. But how are you going to prepare a rod of non-chlorine? Can we prepare a rod of chlorine?
No.
It's
Chlorine is a
non-metals.
gas. So we
Yes.
cannot prepare a rod of a chlorine. So in case of non-metals, we use an inert metal, inert metal for the electrical connection. Yes or no? So what may be the electrical metal, inert metal, which we are going to use for our electrical
Me-
connection?
Argon, krypton, xenon,
No,
radon.
no. They are inert in the sense they are not going to take part in the reaction in the electrochemical process. I'm talking about that, not about inert metal ions.
Sir, gold.
No.
Platinum, silver.
Yes, platinum. Platinum is the correct answer. So inert metal we are going to use is platinum rod. So now what is going to happen? The rod will be used as a platinum rod, and on that rod or near on the surface of that rod, chlorine ion or chlorine gas is bubbled, so that you will get connection of chlorine with the chlorine ion. So by means of this we prepare non-metal ion electrode. Understood this?
Yes, sir.
Yes, sir.
Okay. So now let us move further. What is the next?
Metals sparingly soluble salt.
Metals sparingly soluble. First and foremost, what do you mean by sparingly soluble? Anyone?
Sir, which material has lower solubility?
A bit correct.
Which metal cannot be dissociated completely? Which salt cannot be dissociated completely?
Okay. Now sparingly soluble salt. This is most important for the part. Sparingly. The word sparingly indicates hardly or rarely. What does it indicates? Rarely. So are there some metal ions which are not going to get dissolved in water? Can you give me one or two examples?
Gold, platinum.
Mm-hmm. Again, see gold, platinum. We are not we if they are so costly. There we if we go and use it for our electrical purposes, then the rates would be much higher for our use daily use purpose. See, for example, if our phone battery is containing gold and platinum, as you are saying, so what will be the cost of our normal phone? It will rise tremendously. Any another metal ion example which are sparingly soluble in water? We are talking about water over here.
Zinc.
No. Zinc salt can be easily soluble.
Sir, phosphates.
No.
Magnesium, sodium,
All these are soluble metal ions. I am saying which are not at all soluble. In our regular practicals, for determination,
barium,
yeah, barium is one of them. In determination of chloride ion, we use a test. We add a solution. You have to give me the name of the solution. When we add it, what happens? A white ppt comes. Then you confirm that yes, chlorine present. So what is that solution which you add for confirming the chlorine?
AgCl.
AgNO3. AgCl is formed. So AgCl is a sparingly
Basic.
soluble salt.
Yeah.
Okay. So sorry, Ag silver halides. All silver halides are sparingly soluble. They are not at all soluble in water. So hence they are called as what? Sparingly soluble salt. Then mercury halides. They are also not at all soluble in water. Silver iodide, silver bromide, silver chloride, mercurous chloride. All these are not at all soluble in water. So hence these salts are called as sparingly soluble salt. Any silver halide or mercury halide. Remember this. Whenever you will see silver or mercury, mercury is nothing but what? I am writing the symbol. Wait. Hg.
Hg.
Yes. So silver
Yes.
halides and mercury halides are what? Sparingly soluble. They are not at all soluble in water. So now you got it clear about uh, how is this or what is sparingly soluble salt.
Yes, sir.
Okay. Now we are going to see the construction of our rod. How are we going to construct our half cell? Now I have to consider one of the example. What is the example? AgCl. Okay, let me consider one of the example well known as AgCl. Is it clear? Any problem?
No.
Okay. So now what is going to be present and how we are going to use it? The solution, or let us start from the electrode. Okay, pay attention everybody. The rod will be made from soluble metal. Now in this case, what is the sparingly soluble metal?
Ag.
Okay, so the rod will be
silver,
made of Ag, silver. Is it clear?
Yes.
Okay. On this silver, we are going to coat, or there will be a coating of the sparingly soluble salt. Are you getting me what I'm saying? We are going
Yes,
to
sir.
use a metal which is nothing but same metal which is a sparingly soluble salt. Now this is the sparingly soluble salt. So the metal which is there in the sparingly soluble salt is Ag, silver. So we are going to use the same silver ion, silver metal. Is it clear? So there will be a silver rod. On the silver rod, what is going to happen? Come on.
There will be coating of sparingly soluble metal, AgCl.
Yeah. So see, you can see the diagram. Can you see what I did here?
Yes, sir.
Yeah. So the rod is nothing but made up of silver. Yes.
Yes, yes.
Then this one is nothing but what?
Coating of the sparingly soluble salt,
What is that?
AgCl.
Yes. So now I
Chloride
have
ion.
taken a no, not chloride ion. I have taken a silver rod, and on the tip of that silver rod, I have coated it with AgCl, sparingly soluble salt of the same metal ion. Understood this?
Yes, yes.
Yes, sir.
Suppose if I am taking mercury, mercury is liquid, but still understand that if I am taking mercury, okay, then what will be the coating over here?
HgCl.
Mercurous chloride. Okay. So now you understood up to this about the rod. Then we will talk about the electrolyte. Did you understood about this? All of
Yes,
you?
sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. So the rod is made up of silver. On the tip of that rod, we have coated the sparingly soluble salt. So if silver is there, we have coated with silver halide, that is silver chloride. Okay. Now, what will be present in the solution? What what is going to be present in the solution? So,
Chloride ion.
yes, the anion present in okay, is it clear?
Yes, sir.
The anion, I want common anion, I don't want common cation. Do you understand? So what will be present over here?
Chloride ion.
Cl ion, or you can say HCl. For example, we have done in our previous half cell. So this is a bit tricky one, but you now understood what it is. Yes or no? What we have
Yes,
taken?
sir.
Sparingly soluble metal ion, which is common in the sparingly soluble salt, which we are going to apply at the tip. The coating will be there on the rod. Then the anion, so the anion which is common should be present in the sparingly soluble salt. So by this we are preparing this kind of metal sparingly soluble salt. Are you with me, everyone?
Yes, sir.
Yes.
Yeah.
Yes, sir.
Okay. 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 Now we are with the. You understood this? So if we
Yes,
want
sir.
to abbreviate this abbreviation, metal, yes, which will be in contact with metal, and an anion which will be in contact with the anion in the solution. Understood this?
Yes, sir.
Yes.
Okay. Now the last part which is remaining, which is the last part remaining now?
Redox.
Okay. Now the redox. Now, redox means what? Can anyone give me the distinguish between redox?
Sir, redox means the oxidation and reduction reaction takes
Yes.
place simultaneously.
Yes, redox reaction we have learned in your previous classes, but the word meaning, the word which indicates here means what? Re for reduction, Red for reduction, and Ox for oxidation. Yes or no? So, where there is oxidation as well as reduction simultaneously. So now in this a particular metal ion we are going to use, which has two oxidation state. Can you give me an example of a metal ion with two different oxidation state? Are you getting what do you mean by oxidation state? Say Cu2 plus.
Yes, sir.
Yeah,
Copper.
copper 2 plus, plus copper is having 2 plus only. It is having one, it is having only one oxidation state. But there are some metal ions which have more than one oxidation state. So what are they? Can you give me any example? Common example I am giving you. Fe2 plus, Fe3 plus. Yes or no? Fe2 plus and Fe3 plus. So I'm going to just explain with the help of this. Now Fe2 plus, Fe3 plus is the ion having two oxidation states. So now the solution will contain what? Fe2 plus and Fe3 plus, both the ions. Are you getting me what I'm saying?
Yes, sir.
The solution will contain both the ions, Fe2 plus as well as Fe3 plus, mixture of same metal with different oxidation state. Metal must be same, but the oxidation number must be different. Am I clear, everyone?
Yes, sir.
Yes,
And
sir.
the rod again will be an inert metal. So what will be that inert metal?
Platinum.
Silver.
No, no. Always for electrochemistry, for electrical connection, we are only going to use platinum. Is it clear for you, everyone?
Yes,
Yes, sir.
sir.
So these are the four types of what you can say electrodes, which are also called as ion specific electrodes. They are also called as what? Ion specific electrode. Is it clear for you, everyone?
Yes, sir.
Okay. Now there is a what you can say